Have you ever thought about the hidden tools that really built our modern world? Well, we're about to dive into the incredible story of a mathematical invention that, for centuries, was the secret engine behind a global revolution. We're talking about the story of trigonometric tables.
Our story kicks off with a massive puzzle, one that totally stumped ancient astronomers for centuries. You see, when they looked up at the night sky, most stars moved in these beautiful, predictable arcs. But a few of them, the planets, or wandering stars, were different. They would slow down, stop, and sometimes they'd actually appear to move backward for a bit before carrying on. What on earth was going on?
So, here's how we're going to break down this amazing journey. First, we'll dig into that ancient astronomical mystery. Then, we'll see how Copernicus's big idea created a huge new challenge. After that, we'll witness the invention of the tool itself, explore all the incredible ways it changed the world, and finally, see how its legacy lives on today. Okay, let's get right into it. To really get why this mathematical tool was so desperately needed, you have to go all the way back to the problem that started it all, those weird backward-moving planets. So, this weird backwards dance is called retrograde motion. And for ancient thinkers, this was a huge problem. They believed that the Earth was the center of this perfect clockwork universe. So if the heavens were supposed to be perfect, why were the planets breaking all the rules? It just didn't make any sense. Well, the best answer for a very long time came from an astronomer named Ptolemy, way back around 150 AD. His idea was genius, really. He kept the Earth at the center, but he explained that weird backward motion with this incredibly complex system of circles spinning on other circles. He called them epicycles. And you know what? It was a mathematical masterpiece. It could predict where the planets would be with amazing accuracy, and it was so good it became the standard model of the universe for over 1,400 years.
But to actually calculate all those circles on circles, Ptolemy needed a tool. So he perfected what you could call the world's first piece of mathematical software, the chord table. A chord is just a straight line between 2 points on a circle. These tables pre-calculated those lengths for every possible angle, giving him the raw data he needed to make his whole Earth-centered universe model work.
All right, now let's jump forward in time, because this is where the story really takes a turn. The Renaissance is in full swing, and a Polish astronomer named Nicolaus Copernicus comes along with a radical, universe-shattering idea. And in doing so, he creates a brand new mathematical headache.
Copernicus basically said, hey, what if we've got it all wrong? What if the sun is at the center, not the Earth? This new sun-centered or heliocentric model was just beautiful. It was so much simpler. That weird retrograde motion wasn't a real thing anymore. It was just an illusion, what you see when a faster-moving Earth laps a slower-moving planet like Mars. It was elegant, it made sense, but it had one massive problem. He couldn't prove it with math. And this right here is the absolute heart of the matter. Copernicus had this beautiful, revolutionary theory, but Ptolemy had a 1,400-year head start with a system that, while clunky, actually worked. For anyone to take the sun-centered model seriously, it had to be more than just a nice idea. It needed to be a calculable theory that could predict the planet's positions better than the old system. And to do that, they needed a whole new mathematical engine.
You see, this new model threw up some brand new challenges. For the first time ever, you could actually try to figure out the true distances between planets. For example, you could form a triangle between the Earth, the Sun, and another planet. But to solve that triangle, you needed incredibly precise angles. And you had to do all of this while calculating for the fact that your own planet, Earth, is also hurtling through space. The old tools just weren't up to the task.
And this is where our hero, the trigonometric table, finally enters the story. To solve Copernicus's problem, a tool of completely unprecedented power and precision had to be forged. Now, a tool like this doesn't just appear out of nowhere. It evolved over centuries. It started with the ancient Greeks and their chord tables. Then, centuries later, brilliant scholars in the Islamic Golden Age developed the sine and cosine functions that we still use today. Copernicus himself laid out the theory in his famous book, but the final critical breakthrough came from his most dedicated student, a man named Rheticus.
Rheticus's book, published in 1551, was nothing short of a technological leap. Seriously, this wasn't just an update, it was a total reinvention. For the very first time, all 6 trigonometric functions, sine, cosine, tangent, the whole gang, were all there in one place. And crucially, they were tied directly to angles, which made them way easier to use than the old chord tables. But here's the most important part, the precision. We're talking 10 digits of accuracy. Just think about that. That was the key. That was the level of detail you needed to take Copernicus's elegant idea and turn it into a predictive powerhouse. For the first time, scientists could actually test the theory against what they were seeing in the sky and be confident in the results.
And what happens next is just incredible. This powerful new tool didn't just stay with the astronomers. It spread like wildfire and started solving some of the most critical, real-world problems right here on Earth, kicking off a huge wave of innovation.
First, of course, it tackled its original mission, astronomy. With these new tables, astronomers could finally create super-accurate star charts and, for the first time in human history, calculate the actual scale of our solar system. This was the hard evidence, the mathematical proof that the sun-centered model needed to finally win the argument.
But its impact was felt just as much out on the open ocean. You see, during the Age of Discovery, a straight line on a flat map is not the shortest way to travel on a round planet. Using these tables, navigators could calculate the true shortest path, called a Great Circle route, which follows the curve of the Earth. This saved huge amounts of time, money, and frankly, it saved lives.
And back on land, these tables powered the science of triangulation, which completely changed mapmaking. The idea is simple but brilliant. You measure one line precisely, your baseline. Then from each end you just measure the angles to some distant landmark, like a mountain peak. Using the Trig tables, you can calculate the exact distance to that mountain without ever going near it. This lets surveyors create the first truly accurate maps of entire countries.
The sheer versatility here is just mind-blowing. On one hand, architects were using trigonometry to design the incredible soaring arches of cathedrals and make sure roofs were stable, and on the other hand, the military was using the exact same math to design star-shaped forts that left no blind spots for defenders and to calculate the perfect trajectory for a cannonball to hit its target.
So, let's bring it all into the modern day, because the legacy of this 16th century invention is literally all around us right now.
Let's be really clear about this. The trigonometric table was the computational engine of the scientific revolution, period. It's what allowed science to grow up, to move from just philosophical arguments to a real discipline based on measurement, testable ideas, and mathematical laws. It's the tool that people like Kepler and Newton had to have to figure out the laws of gravity and motion.
And if you think this is all just ancient history, think again. The principles of trigonometry are embedded in almost all of our modern technology. They describe every kind of wave, which makes them the language of physics and electrical engineering. They're at the very heart of the signal processing that lets us stream music and compress photos. And they're absolutely essential for navigating everything from a 747 to a mission to Mars.
So, I'll leave you with this thought. A humble table of numbers, born from a simple desire to understand the strange dance of the planets in the night sky, ended up becoming one of the most powerful tools for transformation in human history. It really makes you wonder, without it, what would our modern world, our maps, our buildings, our technology even look like?